Welcome to our presentation on Arduino's basic input and output. Today, we'll explore the fundamentals of interfacing with Arduino boards, understanding inputs, and controlling outputs. Objectives. The objectives of this laboratory are to introduce the student to Arduino Uno hardware and Arduino software, version 1.05 or newer. We'll also guide you through the process of writing, compiling, downloading, and testing programs specifically designed to control LEDs using digital outputs on the Arduino Uno board. For this laboratory session, you'll need a specific set of materials to ensure smooth experimentation. These include a breadboard with an Arduino Uno, an adapter converting 120 volts AC to 12 volts DC with a capacity of 1000 mA, a digital multimeter for precise measurements, and 220 ohm resistors paired with LEDs. With these materials at hand, you'll be well equipped to delve into the practical aspects of our session. Now, we'll dive into practical experimentation with two key circuits. These circuits will be constructed and tested using various programs specifically tailored for the Arduino Uno. For the pre-lab tasks, you'll be required to write 3 programs for the Arduino. Each program should begin with an initial block of comments providing context and instructions. Additionally, ensure to include comments throughout the code for clarity. Compile each program before the lab session and correct any errors that occur. Finally, make sure to include a copy of each program in the pre-lab section of your report. Any changes made during the lab will be reflected in the final version included in the post-lab section. Program 1A. Write a program to blink an LED on pin N as shown in circuit. The LED should blink 1 time per second, 0.5 second on and 0.5 second off, indefinitely. Draw the schematic using Tinkercad or Fritzing software. Program 1B. Write a program to the 3 LEDs shown in circuit 2 in sequence. Specifically, turn on LED N for 1 second, with the others off, then turn on LED N plus 1 for 1 second, with the others off, then turn on LED N plus 2 for 1 second, with the others off. Repeat this exactly 10 times, 30 seconds total. Draw the schematic using Tinkercad or Fritzing software. Program 1C. Write a program that uses a function blink, K, M, to make an LED on pin K exactly M times, 0.5 second on and 0.5 second off. For example, the command blink, 5, 7, should make an LED on pin 5 blink 7 times. The program should call blink 3 times, from setup, to do the following: make the LED on pin N blink 4 times. Then make the LED on pin N plus 1 blink 6 times, then make the LED on pin N plus 2 blink 3 times. Draw the schematic using Tinkercad or Fritzing software. Thank you for watching. Now, let's move forward to our lab exercise. It's time for the lab exercise. Get ready to experiment hands-on with Arduino's basics. It's where we turn theory into action. Program 2 instructs you to connect a red LED and a 220 ohm resistor to digital pin N, where N is your team number plus 2. You'll then write a program to turn the LED on and off indefinitely. Remember to include instructions to control the LED within the loop section of the program, since the LED will blink forever. The LED should be on for 0.75 seconds and off for 0.75 seconds. Don't forget to draw the schematic using Tinkercad or Fritzing software, run the program to verify proper operation, and demonstrate its functionality to the instructor. Program 3 challenges you to make two LEDs blink back and forth indefinitely. Connect a red LED and a 220 ohm resistor to digital pin N, where N is your team number +2. Additionally, connect a second LED and a 220 ohm resistor to digital pin N +1. Write a program to alternate the blinking of the two LEDs forever, with each LED being on for 0.75 seconds and off for 0.75 seconds. Don't forget to draw the schematic using Tinkercad or Fritzing software, run the program to ensure proper functionality, and document your findings in your lab report. For Program 4, you'll create a traffic light circuit using 3 LEDs, green, yellow, and red. Connect each LED with a 220 ohm resistor to the digital output pins of your choice. Write a program to simulate a traffic light sequence where the green LED is on for 10 seconds, followed by the yellow LED for 1 second, and then the red LED for 8 seconds. This sequence should repeat indefinitely to mimic a functioning traffic light. After writing the program, run it and ensure that it operates correctly. Record your observations and any adjustments made in your lab report. For Program 5, you'll create a switch-controlled running light effects program. Connect 4 red LEDs with their respective limiting resistors, and 4 green LEDs with their limiting resistors to the Arduino board via the breadboard. Write a program that offers a menu-driven interface controlled by 5 toggle switches or tactile push-button switches. The menu displayed on your serial monitor should include options for different light sequence modes. The example menu is shown. Once the program is ready, run it and verify that it operates correctly. Ensure that each menu option corresponds to the intended light sequence mode. Record your findings and any necessary adjustments in your lab report. Thank you for listening. In case of confusion, we welcome any questions you may have. Below are the names of our group members. For further resources and tutorials, don't forget to check out our group's YouTube channel, Group 8 Micro. Thank you for your attention, and we look forward to engaging with your queries.